Now, welcome to chapter 9, lesson 1. We are going today to talk about work. What is the work? And is every force that I apply is a work or no? A work is a force acting through a distance. So, a work is a force acting through a distance. Force with a distance. And this distance must be in the same direction of the force applied of the object. So here I have a work as a force times a distance. And not all the applying force will cause or will make a work, because the distance must be, or the distance must be with the same direction of the force applied. If they are not in the same direction, I will say that this is a force, but this force didn't make a work. So a work is a force acting through a distance where the distance must be in the same direction of the force. So work is done only when a constant force applied on an object causes the object to move in the same direction as the force applied. So when I am standing in the class, I'm explaining for you math or physics. Okay, I'm making a force, applying a force, I handle the box, I'm moving my hands, but I didn't make a work. Why? Because I didn't move, and even I move, my work, my applying force is not at the same direction of my distance. So this is not a work. A work we must have only, we can say the work is done only when a constant force applied, when we make a movement, and when this distance and when this movement has the same direction with the force applied. As you see in this picture here, this is a box. We apply a force, a constant force, to push this box. So the direction of this force is the same the direction of the movement, where the box will move to the right. Now let's see these examples where we can say that what is considered as work done in physics. These are examples of work, like when you push a heavy shopping trolley for 10 meters, you're applying a force. This force, it's make the trolley moving, and also your force now, or the distance that is where the trolley is moving, is the same as the direction of the force. Another example, you lift your school bags upward by 1 meter. You lift it upward, you take it from the ground upward. So where's the direction of your movement? It is upward, and you're lifting the school, so the direction of the force also is upward. So we must know that. If we say that we have a work, the direction of the force is the same as the direction of the distance. If it is not, this is not a work. Let's see now these examples. These are what is not considered as a work done. Like you push against the wall. You push against the wall. Here, your force is acting to the wall, but your distance, that is you're moving backward, so you don't move at the same direction. This is not examples of a work done. Another example, jumping continuously on the same spot. You acting on the force upward, but your distance when you are moving, the reaction of you will be downward. So that's mean Yeah, they are not the same direction. Holding a chair and walking around the classroom. When you're holding a chair, okay, I act with the force when I'm holding a chair. But when I'm moving or I'm going around the class, when I'm going around the class, I'm moving upward. I'm moving, as an example, forward to the right. I'm moving horizontally. But when I am holding a chair, I'm moving. My acting force, the direction of my force is vertically. So they are not. Oh, this is not a work done.
Teacher, can you explain again the first example? You push against the wall.
Here later on, I will see give you. You will see an example how they are not like how they is not a work. I will
Okay.
give there's an example that's drawn. So the work done by a force is defined as the product of the force and the distance moved in the direction of the force. So what is the formula to find the work? It is F times S. The force is the product of the force and the distance. And don't forget, the distance must be, your movement must be in the same direction as applying force. Now, the magnitude of the force F. So when I mean that when you grade or when you increase the force, so the amount of work it will be increased. The greater force that applied is the greater work that will be applied. And also for the distance. The greater distance when you push a car, that's mean the greater amount of work you done. So imagine now which work you make. Oh, I mean like if you move or you push the cart as an example with 5 Newton for 1 meter or with 2 Newton with 1 meter, which one has a greater work done?
The five.
The 5. Because as I told you, greater force, that's mean greater work. And also, if you push or if you act with the same force on a cart, 2 Newton, 2 Newton as an example. But you push the first cart with 5 meter and the second cart with 1 meter. So which one has you will work
5 meter because
greater?
it has wider distance.
The one that has the greater force, the greater distance, that means you have a greater work. Is it clear?
Yes, teacher.
Yes, yes, teacher.
So now here there are two factors that you have to keep in mind when you're deciding when a work is being done. Something that has to move, the things that must move. But if you hold a chair and stand up, you didn't move. So this is not a work. When you take or you lift a chair, when you take it from the ground upward, so the chair is moving upward, your force is upward, so this is a work. But you are moving on the class with holding the chair, your force, our applied force is vertically, but your movement in the class is horizontally, so we cannot say this is a work. So they must make a movement, we must move, and the motion must be in the direction of the applied force. How can we find the work? As I told you, by force times distance. A work is a force times distance. Now let's see these examples here. As I told you, remember that work is not done every time when a force is applied. Not every force make a work. We have some conditions to say that this force make a work. And work is done only when a force moves an object in the same direction as the applied force. We must move in the same direction. We have to move and my movement in the same direction. Look at these examples here. Look at the first picture. The man is the man. No, looking now at the second picture. Is the man doing work when he lifts the box? And this picture here,
No.
he lifts the box. Is he
Yes.
making work?
Yeah,
Okay.
because he moved the box.
In this picture here, when he lifts the box.
No, but he's not moving.
But the box is moving.
Yeah, the box is moving upward, and the force is also upward. So we have here. So the movement distance upward, and the lifting force upward. So we have a work. Now look at the second picture. Here sometimes, like my hand here, my muscles are moving. So we have the movement distance is the same as the lifting force. Now look at the first picture here. When the
Teacher?
man hold the box. Here now. Is there a force?
No.
Force.
No, yeah, there's a
Yeah.
force.
There's a force because he hold the box. Yes, there's a force.
Yeah.
But is there the work now?
No, because it's not moving.
Doesn't? Yes, bravo. They didn't move the box. Now look at the
Teacher,
third picture.
it don't have a work, right? But it has a force.
Yeah. Now look at the third picture here. If the man doing work, is the man doing work if he carries the box?
No. But he has
No.
a force.
Yes, he has a force, but his direction is not as the same as applying the force, so there's no work. Is it clear now?
Yeah.
Teacher.
Teacher, weren't there like some specific cases like when they said that it is perpendicular or something that it does not work? I remember something like that, but not clearly.
Can you remember, please?
Is it-
Perpendicular what?
Like there are some specific cases where we don't count it as being work. One of them was being perpendicular. I remember that, but I don't really remember it clearly.
I will see it, what are these cases, and I will tell you about them.
Thank you.
So look at this picture here. As I told you now, Rose, think about pushing a wall that doesn't move. Here, you push a wall, you act a force on the ball, and this wall here doesn't move. So a force is applied. There's a force, but the wall has not moved a distance. So is this a work done?
No.
No. So here, he applied the force,
Teacher?
but the wall is not moving. I told you the force must move an object. And if it's move it, must be in the same direction. But here, the applied force didn't move the wall, so we cannot consider that this is an work. Yes, Rose?
And it's even not in the same direction because it will go against the wall, right?
Sorry? But can you raise your voice?
And in the same time, because he is not moving in the same direction. Teacher, can you hear me?
Ah, yes, no, yes, now. You mean when the reaction
Yeah, I
force
said
will yes, the reaction force will not be with the same direction, so this is not a work done. Is it clear now, Rose?
Teacher, thank you so much.
Yeah. Now let's see now these examples here how to calculate the work. Work, as I told you, it is a force times distance, or F times D. The unit of force is Newton, and the unit of distance is meter. So the unit of work, it will be joule. Joule is 1 Newton times 1 meter. Or in words, we say that if you lifted an object weighing 1 Newton through a distance of 1 meter, so you did 1 joule of work. 1 Newton times 1 meter. So if you're lifting an object weighing 1 Newton through a distance of 1 meter, so you apply a force. We did a 1 joule of work. So the work is F times D. This is a unit for the work, and its unit is joule. Work is in joule. Let's see now these examples. If you lifted an object weighing 200 Newton through a distance of 0.5 meter, how much work would you do? So here you have a 200 Newton. So this is the force. So you lifted it with a distance of 0.5 meter. Every time when you lift an object, that means there's a work done. So to find the work, you will say that a work, or the formula of the work, as we know, it is a force times distance. Force times distance. Where's the force? It's 200 Newton. Where's the distance? It's 0.5. So when you multiply 200 by 0.5, you will get 100 joule. Don't forget that the unit of work is joule. Let's see another example. Now, you are helping to push your mother's heavy shopping cart with a force of 50 Newton for 200 meters. So here, you are helping your mom to push the cart. So you're applying forces forward. The distance of the movement of the cart, it will be also forward. So you apply a force. You apply a force with the distance. So there's a work done. Now, what is the magnitude of this work? We say that a work is a
Times
force
distance.
times distance. A force is 50, and the distance
200.
is 200. So which is 10,000 watt. Or we can write it as 10 kilowatt. Kilowatt, that's mean it is 10, or it's mean 1000 watt. So
Yeah.
kilowatt, it's mean 1000 watt, like kilogram. So 10,000 watt, it's mean 10 kilowatt.
Teacher, can I just say it's 10,000 J?
And not kilowatt. I'm sorry, I'm going to electrical power. Kilojoule, sorry. I'm sorry.
It's okay, teacher.
It is 10,000 kilojoule.
Okay.
I'm sorry, I'm just oh,
No, it's
I'm
okay.
thinking like physics grade 11, because when I told them about the power and what. So here, this is in joule.
Teacher, 1 joule
10,000
equal,
joule, or
uh,
10 kilojoule. Yes.
teacher, 1 joule equal how many kilo? Wait, 1 joule equal how many kilo joule?
No, kilojoule is 10,000 joules. 1,000.
Like 1? Okay.
I'm sorry. Kilojoule is 1,000 joules.
Okay.
So if I told you now
Thank you,
10
teacher.
1000 joules. So if this 10 thousands, it can be written as kilojoules. So I have 10 kilojoules.
Teacher,
Yes,
teacher, what was the unit of the impulse?
impulse of the momentum,
It was,
change of momentum.
in physics, we wrote it as B or as M.
The momentum is F times S. F times
Yeah,
the
and
F
the
times
unit of
the
physics, we can wrote it as B, right? The momentum.
Newton times meter.
Okay. And we can write it, I mean the letter in the impulse, we can write it as B or M.
I told you there's some books write it as P, some books write it as, يعني just write it as an impulse in the physics in my quiz.
Okay, teacher.
And some of the books write as P, some of them write as I.
Oh, okay. Thank you, teacher.
You're welcome. Now, do you have any question here?
No,
No, thank you.
This is the definition of work.